Hi students, welcome to Max Point of View. Today we are going to solve each and every numerical which is there in the textbook from the chapter Conservation of Energy, which is part C of Work Energy Power chapter. Okay, now before starting our first question, my suggestion is I want you to watch both the concept video and the theory questions which is there in the textbook. I have solved everything and those two videos are available separately and both are available in the description box. If you have that concept, then solving numerical is very easy for you. So without wasting any time, we'll start our first question. Question number 1. A ball of mass 0.2 kg is thrown vertically upward with an initial velocity of 20 meter per second. Calculate the maximum potential energy it gains as it goes up. So first question itself, it is little confusing. Why? Because you will get to know once we write the given data. See, whenever you are solving a numerical, first write the given data and make sure all the written data is in SI units. So first we will write the given data. First question. So mass is given as 0.2 kg, correct? Then what is given? Initial velocity, that is nothing but u, as 20 meter per second. Then we have to calculate the maximum potential energy. Okay, listen, first you need to understand the concept properly. Whenever you throw a ball or any object, so whenever you throw, you have to throw it with the initial velocity, correct? Whenever any object goes up against the gravity, its potential energy will keep on increasing. How it will keep on increasing? Because the kinetic energy, whatever the kinetic energy it has while moving, will be converted into potential energy. So if we use kinetic energy formula, that is nothing but potential energy. Why? Because kinetic energy is converted into potential energy. Now, so U, potential energy, is nothing but what is the formula for potential energy? mgh. But here we are not going to use it because we have m. Okay, we can assume g as 9.8 or 10. What about h value? So we have to use kinetic energy formula. So what is the kinetic energy formula? Half mv square. Here instead of v we are using u. Why? Because it is initial velocity. So in the given data they have given initial velocity as 20 meter per second. So instead of v we are using u. Now we'll substitute the values. We will get the answer directly. Half into what is the value of mass? That is 0.2 into velocity value 20. We have 20 square. We can write it as 20 into 20. So 2 ones are 2 tens are. Now we have 0.2 into 10 into 20. So this is nothing but 40 joules. That's it. For kinetic energy or potential energy, unit will be joules only. Question number 2. A stone of mass 500 grams is thrown vertically upward with a velocity of 15 meter per second. Calculate the potential energy at the greatest height, the kinetic energy on reaching the ground, the total energy at its halfway point. So if you have known the concept, then this question is very simple. Why? Because you will understand with the diagram as well as with the answer. Listen, first we will write the given data. Mass is given as 500 gram. Okay, see, I told you all the data should be in its SI unit. What is the SI unit of mass? Kg. You have to convert this gram into kg. 500 gram divided by 1000, it is nothing but 0.5 kg. Okay, then 15 meter per second. So velocity is given as 15 meter per second. What is the SI unit of velocity or speed? That is meter per second. So no need to convert it to any unit. Now this is very much important. So first sub question A, see the potential energy at greatest height. Greatest height we have to find. See, we cannot find potential energy without kinetic energy, correct? Because whatever the kinetic energy I have, assume I am throwing a ball. Okay, now I have kinetic energy. Whatever the kinetic energy I have, that will be converted into potential energy. See, first you have to understand this diagram. Assume this is the ground and we have a ball here. Now whenever I throw this one up, I have a kinetic energy, correct? So I have kinetic energy while throwing up. Now once it reaches this maximum point, okay, whatever the kinetic energy I have, that will be completely converted into potential energy. So at this point, whatever the kinetic energy I have, that is nothing but the potential energy at the maximum point. Okay, now whenever the ball reaches this point and it start falling down, correct? So it has maximum potential energy. At this point it has only potential energy, no kinetic energy. While falling down, whatever the potential energy it has, it will keep on decreasing till here. At this point, whatever the potential energy it has, it will become zero. The complete potential energy will be converted into kinetic energy. So whatever the energy I have here, that is same as the maximum point. So whatever the maximum point here, while reaching at this point, okay, will have the same value. Then what about any other point apart from these 3 points? Okay, listen here. Assume here, okay, at this point or this point. We'll talk about these 2 points now. So if you understand this one, finding answer here will be very easy. That is why I'm teaching you this one. Now we'll talk about this point. Now assume I have only kinetic energy. Okay, when you throw it up, okay, it start moving with the energy, correct? Assume it has 100%. Now it has reached, okay, halfway here. Whatever the 100% kinetic energy I have, that will be converted, 50% will be converted into potential energy, correct? So at this point I have 50% of kinetic energy and 50% of potential energy. At this point, assume this has covered 90% of this path to this top. Okay, now I have 90% of the potential energy and only 10% of kinetic energy. Now we'll talk about this point. Assume it has covered around 40% of from here to here. So when it is covering, okay, 40%, okay, now it has reached 40% of this distance. So 40% of the potential energy will be converted into kinetic energy. At this point we have 60% potential energy and 40% kinetic energy. So at any point, if you take any point here, the total conserved energy or total mechanical energy will be same. Why? Because what do you mean by mechanical energy or total energy? It is the sum of kinetic energy and potential energy. Here if I have 40% kinetic energy, 60% will be potential energy. Here I have 20%. Assume I have 20% kinetic energy, then 80% will be potential energy. When you add it, the total mechanical energy will be same as any other 3 points. So if you have understood that, then answering these questions will be very easy. Listen, potential energy at the greatest height. See, I cannot use potential energy formula because we don't have height. So we can use kinetic energy formula. So this will be half mv square. What is the mass? That is 0.5. What is the velocity? That is 15 into 15. Okay. Now if we multiply all these values, we will get 56.25 joules. That's it. Now we'll talk about question B, sub question B. The kinetic energy on reaching the ground. I told you whatever the energy we have here, okay, at this point we have only potential energy, no kinetic energy. Here when it reaches ground, all the potential energy will be converted into kinetic energy. So whatever the potential energy I have, that is nothing but kinetic energy. Whatever the potential energy I have, that is nothing but kinetic energy. So kinetic energy will be equal to potential energy, that is nothing but 56.25 joules. Now third sub question, the total energy at halfway point. Listen, total energy conserved is nothing but mechanical energy, correct? Mechanical energy. See, halfway, we are talking about halfway, correct? So half, what is mechanical energy? Kinetic energy plus potential energy, correct? So halfway, okay, we are talking about only halfway, that is why I am using 1/2. If they are asking 1/4 of the point, okay, or 1/4 path, then you have to take 1/4. If they are talking 3/4, then you have to take 3/4. Now they are talking about half is nothing but 1/2. What is total energy? Is nothing but kinetic energy plus potential energy. So that is equal to half plus half into 56.25 plus 56.25. We can use the bracket. So that will be equal to 56.25 joules. That's it. Okay, see, if you have seen the concept video, this is what I have explained. If you understand this concept, then finding the answers are very simple. See, this is why few students think numericals are very difficult. See, numericals are not difficult, they are logical. Okay, there is a logic behind the question. If you don't understand the question, then this question is very difficult. See, if you have the knowledge, if you have the concept, then answering these questions are very simple. All the three questions have same answer. Question number 3. A metal ball of mass 2 kg is allowed to fall freely from rest from a height of 5 meter above the ground. Take G value as 10 meter per second square. Calculate the potential energy possessed by the ball when it initially at rest. Now we'll solve one by one, they will understand everything. Okay, this is question number 3. What are the given data? Mass of the ball, that is 2 kg. Then height is given, that is 5 meter. G value we have to take it as 10. Don't worry about the unit only when it comes to G. Apart from that, everything should be in SI unit. What is the unit of mass? Kg. What is the unit of height or length? That is meter. So both are in safe mode. Okay, now we have to find the potential energy. What is potential energy formula? First one, potential energy is nothing but mgh. All the three values are here, correct? So mass 2 kg, G 10 into 5, 2 5s are 10, 10 into 10, that is 100 joules. Next, second one, the kinetic energy of the ball just before reaching the ground. That is nothing but whatever the potential energy we have. If you have understood the previous question, whatever the potential energy it has, maximum potential energy or only potential energy, that is nothing but the kinetic energy value, correct? So kinetic energy is equal to potential energy before reaching the ground, that is nothing but 100 joules. Now the third sub question, what happens to the mechanical energy after the ball hits the ground and comes to rest? Assume a iron ball, you left it like this and it has reached the ground and it has come to rest. What happens? It hits the ground and there will, because of the friction, heat will be generated, and because of the friction there will be sound. So when the ball hit the ground, there will be sound energy and heat energy. That's it. Question number 4. The diagram given below shows a sky jump. A skier weighing 60 kg stands at A at the top of a sky jump. He moves from A and takes off for his jump at B. Listen, it's a very simple question. First we need to understand the question, then we'll go for the calculation part. Okay, listen. A skier, this is a sky jump. Okay, a skier is standing here and his mass is 60 kg. He is going to jump from point A to point B. So this is the concept. Now we'll see the questions. Calculate the change in gravitational potential energy of the skier between A and B. See, first we'll solve this question, then we'll go for the remaining questions. This is question number 4. We'll write the given data. Okay, so mass of the skier is 60 kgf. Okay, now here we are talking about two heights, correct? So at point A the height is 75 meter, at point B it is 15 meter. So height 1 is 75 meter, height 2 is 15 meter. Okay, here we have to take G as 10. Don't worry about the unit, only when it comes to gravity. Apart from that, we have to make sure everything in its SI unit. Okay, here mass is in kgf, kg or kgf, anything is okay. Apart from these two, okay, whatever is there, gram is there, you have to convert into kg and substitute the values. Kg or kgf is fine. Okay, now first we'll talk about the first question. Calculate the change in gravitational potential energy of the skier between A and B. Listen, assume he is standing here, so the height is huge, correct? Height is huge, that is 75 meters, so it has higher potential energy. Now when he moves from point A to point B, height is very less, correct? So potential energy decreases. That is what he is asking, how much potential energy it has been decreased. So now what we are going to do, first we will calculate the potential energy at this point, then calculate the potential energy at this point, we'll subtract, we'll get the answer, right? Instead of doing that, if we will get the right answer, instead of doing that, we have a simplified formula from the textbook, we'll use that only. So first sub question, change in potential energy. So that is nothing but U is equal to mg h1 minus h2. So why we have to use h1 minus h2, why not h2 minus h1? You have to see the question. It can be h2 minus h1 also, that depends upon the value. In both the cases, which has maximum value h1, that is why I am using that first. If I use the minimum value here, we will get the answer in negative form. We don't want that. Okay. So mass is nothing but 60, g is nothing but 10, here h1 is 75 minus 15. Okay. Once we solve all these things, see 75 minus 15 is 60. 60 into 60, 3600 into 10, 36 into 3 zeros. So 36 3 zeros joules. That's it. Okay. Second question. We'll talk about the second question. If 75% of the energy of part A, okay, becomes the kinetic energy at B, okay, at B, calculate the speed at which skier arrives at B. Very simple question, very logical question, actually not a simple question, logical question. If you understand the concept, then we can easily write the answer. Listen, he is telling 75% of the energy from part A is converted into kinetic energy at B. Okay, whatever the energy we have at part A here will be converted, 75% of this energy will be converted into kinetic energy at B. Okay, at that point, okay, before reaching B, what was the velocity? So that is very simple. First we will find the answer for what is that 75% of kinetic energy. Once we find that, we have kinetic energy, okay, then we have mass, it is easy to find velocity, correct? So first we will find 75% of that kinetic energy. Okay, that we can easily find 75% of 36,000 joules, correct? So here 75, to get rid of this percentage, I'll put 100. What do you mean by half in mathematics? That is into, so joules. Okay, now this is not the final answer. If we calculate all these things, we will get the answer as 27,000 joules. 27,000 joules. Now we got the, what is that 75% of kinetic energy. Now we have to calculate velocity. See, what is kinetic energy? K is equal to half mv square, correct? So here, so we want to find the value of v, correct? Now we'll substitute the values, we'll get the answer directly. Okay, listen, kinetic energy will be 27,000 into 2, because I have moved this to this side, and here we are remained with m and v square, correct? mv square, I'll move this m this side, so that becomes 60, correct? See, very simple. I move this m value. What is m value? 60. When you move this m value this side, that becomes division. I have moved this to this side, okay, to LHS. Division becomes multiplication. Now we have to find v square, correct? So v square will be, see, v square will be, once we solve this one, we will get the answer as 900. So if we want just v, square root of 900, that is nothing but 30 meter per second. See, this is how we will calculate the answer. See, these kind of things you will feel it is little difficult. If you know the logic, if you understand the question properly, you will get the answer. They are telling 75% of the kinetic energy is converted from part A. So what is that part A? 36,000. 75% of that 36,000 will get 27,000. We have kinetic energy, we have mass, we have to find velocity. That's it. Question number 5. A hydroelectric power station takes its water from a lake whose water level is 50 meter above the turbine. Assuming an overall efficiency is 40%, calculate the mass of the water which must flow through the turbine each second to produce a power output of 1 megawatt, and gravity value is given as 10 meter per second square. Okay, listen, in this question there are so many things, but it is little logical. I will teach you everything, don't worry about it. Once you learn the concept like this, you have to apply for a different question, because we cannot expect the same question to appear in the exam, right? So learn the logic, apply there in the exam. Okay, this is question number 5. First we will write what are the given data. Okay, the efficiency is 40%. This is the efficiency symbol, correct? Efficiency is 40%. What do you mean by efficiency? That is nothing but only useful work, correct? Useful work is only 40%. Then height is given as 50 meter. Then power is given as 1 megawatt. 1 megawatt is nothing but 1 into 10 power 6 watt. Okay, then G value is given, that is 10. Don't worry about the unit, only for G. Okay, see the other units. Height is in meter, power is in watt, then all of them are in SI units. Now we'll go for the action. Now they have given 40% of efficiency, that is nothing but useful work done. Okay, useful work done. See, from the previous part itself we have learnt whatever the work is done, okay, if it is related to kinetic energy, work done will be equal to kinetic energy. If it is related to potential energy, whatever the work done is nothing but potential energy. Here we are talking about height. So height is nothing but potential energy. So whatever the useful work is done, that is nothing but potential energy. So here we have to find the mass of the water, correct? So we'll use all the given data to find that. Okay, useful work done, useful work done okay, will be equal to 40% of, okay, potential energy, correct? That what you mean by that? Whatever the water is here, so when it falls down, all the complete potential energy will be converted into only 40%, okay, useful energy. Whatever the 100% potential energy is there, that will be converted only 40% as useful energy. So whatever the potential energy we have, if we find 40% of that, then that is enough. Now 40%, how will remove this percentage? That is nothing but by 100. Half is nothing but multiplication. U is nothing but potential energy. What is the formula for potential energy? mgh. So here m, we have to find, m is nothing but the mass of the water, that is what we have to find. So for 0 0 get cancelled. 4 divided by 10 into m into 10 into what is h, that is given as 50, correct? So 10 will get cancelled. 4 5s are 20. We have 1 0, so I'll put that 0 here. And what is remained? See, we cannot write unit here because we have no value for this mass. Mass is nothing but mass of the water. We will write it as it is, mass. Okay, now whatever the work done is nothing but 200 times the mass, correct? So what do you mean by power? Power is nothing but work done by time, correct? Work done by time. In this question we are talking about for every second. For every second 40% of the potential energy will be converted. So time will be 1 second. So time we have to take it as 1 second. Now power value is given, that is nothing but 1 megawatt. 1 megawatt is nothing but 1 into 10 power 6. So 1 into 10 power 6. What is the value for work done? 200 into mass. 200 into mass divided by time. Time here we are taking it as 1 second. So 1. So what we want? The mass of the water we have to find. So to find that, you move this 200 here. So 1 into 10 power 6 divided by 200 is equal to mass. 1 into 10 power 6 is nothing but 1 followed by 6 zeros by 200. For 2 zeros, 2 zeros get cancelled. See, we have remained with 10,000. 10,000 divided by 2. Whenever you are dividing any number by 2, okay, what do you mean by that? You are making it as half, right? So 10,000 divided by 2, that equal to 5,000. We are talking about mass of the water, so unit will be kg. That's it. Question number 6. The bob of a simple pendulum is imparted a velocity of 5 meter per second when it is at its mean position. To what maximum vertical height will it rise on reaching its extreme end if 60% of energy is lost in overcoming the friction of air. Take G as 10 meter per second square. Okay, this is a logical question. First we need to understand the question. Okay, before that we will write the given data. Okay, listen. Velocity, it is given as 5 meter per second. Then okay, 60% of energy is lost. Okay, energy loss is 60%. Okay, see, in the question we are not going to use what is the loss of energy, correct? Now we are going to use how much energy is available. Available energy is 40%, correct? So this is what we require. We don't want how much energy is lost. Okay, now we have to take G as 10. Then we have to find the height, correct? We have to find the value of height. Okay, here you need to understand few things. Okay, listen. See, okay, this is the bob of a simple pendulum, right? Now assume this bob is moved somewhere. While coming back to the same position, mean position, the velocity is 5 meter per second. It has moved somewhere. While coming back to the same mean position, the velocity is 5 meter per second. Now from this position, while moving in this direction, 60% of its energy will be lost due to the air friction of air. Now because of that air loss, how much height, okay, how much distance it will travel in this direction, that is what we are going to calculate. Okay, for that velocity, energy available is important. Okay, not energy lost. Then gravity value, height. See, whenever we are talking about velocity, we have to talk about kinetic energy, correct? Whenever we are talking about height, we have to talk about potential energy. So in this question, whenever something is moving, okay, something is moving apart from these three extreme ends, we know somewhere here we know that we have both kinetic energy and potential energy. We have both kinetic energy and potential energy. At this point we have only potential, and this point we have only potential. At this point we have only kinetic. Apart from these 3 points, anywhere we have both kinetic energy and potential energy. So here we have to assume that energy conservation method is nothing but energy conserved will be equal to kinetic energy to potential energy. Kinetic energy will be equal to potential energy. Now we don't have complete kinetic energy, correct? So while moving, 60% of the energy is lost. How much is remaining? 40%. So we don't have complete kinetic energy, we have 40% of kinetic energy. 40% of kinetic energy will be equal to potential energy. So now we'll apply the formula. 40% I can write it as 40 by 100 into kinetic energy is nothing but half m v square, correct? V square is equal to what is u, that is m g h, correct? Now we'll substitute the values. 40 by 100 into 1 by 2. Okay, in both the cases we have m, correct? We can cancel it. Now we have v square. What is v? That is 5. V square is 5 into 5 is nothing but gravity, that is nothing but 10 into h. So these are the values. Now we want h value, we will send this 10 that side. Okay, see, I am just sending this 10 this side. So h is equal to I'll write all these things as it is. 40 by 100 into 1 by 2 into 5 into 5 into 5. Okay, I have sent this 10 this side, so here this becomes divisible by 10, correct? So for 1 0 get cancels. Next, 2 1s are 2 2s are. See, this is my method of calculating the answer. You can use any method to calculate the answer. Whatever the answer we are going to get, that will be the same. Okay, now we have 2 here, 2 1s are 2 5s are, correct? 5 1s are 5 1s are, whatever we have 5 by 10. See, I think you have confused. Whatever the value you have, you try to calculate in your own way. So 5 by 10 is nothing but half. 5 1s are 5 2s are, 1 by 2 is nothing but 0.5 meter. That's it. Question number 7. The figure alongside shows a simple pendulum of mass 200 grams, it is displaced from the mean position A to the extreme position B. The potential energy at the position A is 0. At the position B, the pendulum of mass is raised by 5 meter. So this is the concept. Don't worry about the question. First we have to understand the concept. First we will write the given data. Okay. Question number 7, mass is given as 200 grams. So it is in gram, we have to convert into kg, that is nothing but 0.2 kg, correct. Then height is given as 5 meter. Then any other data? No. Okay, first we need to understand the concept here. Listen, very simple. See, at mean position, okay, at mean position, now assume the pendulum is moving. When it comes to this position, at this position, height will be 0. So this is very much important. This is what we have learnt in concept video. If you haven't watched it, then these questions will be difficult. So watch the concept video, solved theory question, then numericals will be easy. Listen, at position, mean position A, potential energy will be 0. Why? Because height h will be 0. Correct. That is what given in the question. If the potential energy is 0, we have only kinetic energy, that to maximum kinetic energy. Maximum kinetic energy. Now here, okay, at this point, extreme end B and extreme end C, okay, when it reaches this position, okay, the height will be maximum, correct, height will be maximum, and for a fraction of second it is not going to move, it is not going to move. Then if it is not moving, okay, the kinetic energy will be 0, it has maximum potential energy, it has maximum potential energy. So at position A, mean position, it has maximum kinetic energy, no potential energy. At position B and position C, it has maximum potential energy, no kinetic energy. So maximum potential energy will always be equal to maximum kinetic energy. So whatever the value we have at B, that will be equal to value of A. Okay, that is nothing but the value at C. If you know this concept, then solving this question is very easy. Now we have to calculate the potential energy at the position B. Okay, very simple. See, at this point we have to calculate a potential energy at B. Okay, what is the formula? U is equal to mgh. In this question they have given G value as 10. Okay. Listen, we'll substitute the values, we'll get the answer directly. So mgh, mass value, that is 0.2. You should not substitute gram, it should be in kg. Gravity is 10, height is 5. Okay, 0.2 into 10, that is 2. 2 into 5, that is 10 joules. That's it. Okay, now sub question B, we have to calculate the total mechanical energy at point C. What do you mean by mechanical energy? The sum of both potential energy and kinetic energy. When we add both kinetic energy and potential energy, we will get the answer for mechanical energy, correct? So at C, I told you earlier, okay, at C we have only potential, that is maximum potential energy. We don't have kinetic energy. So whatever the value is at B, that will be equal to A, that is nothing but C. Okay, so here we have maximum potential energy of 10 joules. At C, we have only potential energy, no kinetic energy. So, mechanical energy at C, okay, mechanical energy will be K plus U. Okay, K kinetic energy plus potential energy. Kinetic energy will be 0. Potential energy will be mgh. That is nothing but, so m is nothing but 0.2 into 10 into 5. So, 0.2 into 10 into 5, that is nothing but 10 joules only. Now the third sub question, calculate the speed. What is the speed of the bob when it reaches A from B? Assume the bob is right here now. Okay, when you leave it, okay, with the same example, when it comes to this point, when it goes back to mean position A, what is the speed of the bob? What is the speed of the bob? So if they are talking about speed, they are talking about kinetic energy, correct? So do we know what is kinetic energy? No, we have mass. What is kinetic energy? Half mv square. Okay, v square, that is what we have to find. We have only mass, we don't have kinetic energy. I told you earlier, see, at this point we have only potential energy, no kinetic energy. At this point we have only kinetic energy, no potential energy. At this point, whatever the value we have, okay, that will be equal to this point. So at this point, okay, at A, K will be equal to U at B. At A, kinetic energy will be equal to potential energy at B. So U is equal to K is equal to 10 joules. So we got to know that kinetic energy, correct? So once we have kinetic energy, we just have to substitute that value in the formula, we'll get the answer directly. So what is the formula? K is equal to half mv square. We have to find the speed of the bob, correct? So half mass is given as 0.2 into v square. What is the kinetic energy value we have? That is 10. So if we move this 2, okay, and this 0.2, so this becomes 20 by 0.2 is equal to v square, correct? So 20 by 0.2 is nothing but 200 by 2, correct? 20 by 0.2 is nothing but 200 by 2. 200 by 2 is nothing but 100. So v square is equal to 100. If you send this square that side, that becomes square root. What is square root of 100? That is nothing but v is equal to 10 meter per second. That's it. So if you know these logics, then solving every question will be very easy. So now we have completed all the numericals from the part C, conservation of energy. Now we have solved concept videos based on conservation of energy, and we have solved all the theory questions. Now we have solved all the numericals from the textbook, correct? So if you learn like this, 99% you will be ready for the board exam. 1% will be for application oriented question. Don't worry about it. You will definitely get the answer because you have all the logics. We have solved all the question. The students, the main mistakes from the student is they don't solve all the questions from the textbook. They'll study the concept, they'll think they'll know everything, but when it comes to different logical questions like this, they will never answer it because they have the concept, they don't have the logic. While solving the different question, they will get the logic. So that is why my suggestion is solve each and every question from the textbook. 100% you will be ready for the board exam. Thank you.